Hello everyone, let's maybe wait a few more minutes until others join, and then we'll start. Okay, I guess we can start. Hello everyone. So today we're going to continue with the agenda I shared last time. And so before we start, maybe some points about it. So first of all, maybe please let me know. I see that you already started splitting into the groups. So maybe if there is anyone who does not have a group or just yeah, then please let me know about it. Uh, in case there are only two groups, then we can also actually proceed with two groups. It's not it. In this case, it doesn't really matter how many participants there are in one or another group if there's equal number of the participants in each group. Because the main idea is that so there should be the groups with we have yeah, four people. That's fine as well. I mean that it's not mandatory that you should have a group of 5 or 10 maybe yet. So that's up to you how you can manage this. Yeah. The main idea is that one of you creates a remote repository, and then others can easily proceed with the changes on this repository. Yeah, the main idea for this 7th assignment is to share, yeah, to share the remote repository with others, and then to see how it is if you work together on the same remote repository. So that's the aim of the task. If someone is struggling with finding a group, then please let me know now or after the session, and then split your groups, or let's see how many people there are. Okay, so that's about splitting into groups. About Git, so I see that some of you already started working on this assignment, on this Git assignment, or finished it. That's also really good. In case you have any questions about Git, then please let me know if something is not clear. And now we can move on. Before we move on with the topics mentioned here, as you remember yesterday I had this one issue with the user authorization. That was actually the setup, that's not actually Git setup, but that was the setup of my computer. As you remember, the issue was that actually in GitHub, before the session I created the test user, that was my sandbox user, and then after this, during the session I created another user, and I had the issue to re-log in with this user. And the idea is quite simple. That was from Windows side, and so that was related to the credentials stored on Windows. So actually, when you use GitHub and you sign in with your username and password, for GitHub and also for Bitbucket, the username is your email. Register now. And after that, all the credentials are stored not here, but so yeah, under control panel. Tab control panel, you'll see you have credential manager. So theory here you should have all the credentials stored on your computer, then you can go to those credentials. Let me just not show you all the credentials I have, and maybe show some of them. Hold on. And here we can see there is the credential for GitHub. So actually I have two of them. Guess I can remove this one. So previously I had the sandbox user stored here. So if I remove it from here, then for now, next time when I try to access to try to do any changes here, so let's make some changes. Let's maybe change this file. Yeah, remember, Git tracks only the files which are changed. So it means they're added or deleted, or the content of the files is changed. In this case, only in this case you can stage the changes. So same way as I will do it now. Stage all the changes. Then I can commit the changes staged. Yeah, and after that, yeah, at this point I only work with the local Git repository. I don't touch the remote repository. And so staging and commit and Git commit happens only on local level, yeah, on the level of the local Git repository. And at this point, when I call the command git push origin master, at this point I push the changes to the remote repository, and so at this point you will see this GitHub login. Yeah, and now you can type username and password. So let me do it. So now I have this username and password. Maybe I will have logon failed. Moment. Okay, actually, at this point that was fine. That was fine, but one more thing, I guess I could also maybe check again. Oh no, it's here. That should be fine. So in case something does not work, you can also delete this one. Yeah. So after that, you can log in from the beginning, but that's just an exceptional case. Usually you do not switch between the users in GitHub. Yeah. So normally you should have just one user and then log in once and work with it all the time from the computer. Alright, so now let's move on with another topic. Now it's .NET capabilities. I will take a small part from it because we need to move on. So, and at this part we will quickly I'll quickly tell about the differences between. We'll go to 15 slide. I'll quickly explain the difference between .NET and Java, because actually these two languages are, from their usage point of view, mostly from the usage point of view, and mostly from the practical point of view. I mean, how these two platforms, Java is actually a programming language, but so in this case we compare Java with .NET. So in this case it's a little bit interesting that we compare the platform, the framework with programming language. But in this case, Java is not actually, Java in fact is not only the language, but it's also the platform which has some similar things used in .NET. I mean, similar from the point of view that we need to install something, and we need to install some things. for Java as well as we did start for .NET. But only after that we can use Java, the same as .NET. And yeah, also in addition, if you learn the programming, then in fact if you learn .NET, then you can quickly switch to Java, and in the opposite way, if you do something with Java, then after that you can also easily switch to .NET. But yeah, so now let's take a look on some facts. In fact, Java and .NET, there are two leading technologies now in the development of desktop and some kind of applications. Yeah. So that's true. Both platforms use high-level programming languages. Yeah. So Java uses mostly Java and Java language, and .NET uses mostly C#. Yeah, both Java and .NET, they're referred to as frameworks. Java has, yeah, so for .NET we have three main, and in .NET starting last year we have three main parts, yeah, .NET Framework, .NET Core, and XAML. For Java, there's mostly Java library, but in addition we can also download for Java more different libraries, more different frameworks, and then use them in our programs. So in this case, the concept is so quite similar. Yeah, but sometimes they're both referred as frameworks. Yeah, but .NET is actually a framework itself, but Java is mostly a programming language, but as I just said, it's also considered as a framework because of the additional setup needed to be done. Yep, and yeah, in fact, the platform uses ASP.NET for web application framework that allows developers to create web apps. And here you can quickly take a look on how .NET and Java are used, where they're used. Basically, both of them, so now it should be somewhere here for ASP.NET. That's for web applications. Java is .NET. They both are used by high traffic sites, and so. But comparing to Java, .NET, ASP.NET is used by many users, small users. And yeah, so let's continue with the facts. So Java and .NET are, as I just said, they're one of the most popular technologies now to build web applications. Most businesses use them as the tool. There are lots of different tools and site tools, site programs, site applications built on JavaNet, which also helps us to work with some different and important things in our daily life. And yeah, so there are the main advantages and applications. Before you select the platform, you need to know them, and that best fits your need. And yeah, so right now, let's take a look on the main differences and why sometimes we consider using .NET and why sometimes people in general use Java as well. Yeah, first of all, the Java Enterprise Edition that can work on any operating system. Yeah, so from the beginning, yeah, so Java its platform is 100% platform independent compared to .NET, which is actually platform independent. It's open source and can turn on any OS start use. So basically from last year, yeah, when all the frameworks are merged into one .NET. Yeah, but before that, .NET was mainly used on Windows. Right now, nowadays, it's also mainly used for Windows, but of course, since now it is fully open source, and available actually for all the operating systems. Obviously, the usability of .NET will be increased and it will be used in more for the development in more programming applications, software applications. Yeah, so for Java, Java application, I guess for most of you who uses Windows, I guess you all have Java installed. For some, because also for people who don't program in their life, they also for some reasons they need to have Java virtual machine installed on the computer because there are some different applications which require Java to be used. And so that's mostly also from my experience. Before I started the programming, of course, Java was on my computer and it was needed for some applications. So that's quite common thing installed on Windows computers, and of course also for Linux and Mac computers as well. And yeah, so basically the idea is for Java virtual machine that if you have it, then you can simply run any Java application, any Java code. There are some restrictions on the versions maybe, but if you have the latest version, then everything should be fine. Yeah, both platforms support programming with such programming languages like PHP, Ruby, and Python. Java also use some language which are actually in some way we can call of JavaScript, but Clojure, Groovy, and Scala, they're derivatives from Java itself. Also in addition JavaScript, which is actually maybe for you it's also for future that would be nice if you don't mix up Java and JavaScript, because these are two absolutely different and non-related languages. Yeah. So JavaScript is mostly for web development, it's a scripting language, but Java that's mostly for the applications, for the backend, and such main core logic. Comparing to Java, .NET, in .NET there are such languages like C#, as we all know, F#, which is mostly functional language. That's kind of not really functional version of C#. The syntax is maybe a little bit different, but that's related to the functional programming. We'll later talk about what the functional programming is in general, then also Visual Basic Net, C++, which also is used for some Java applications as well. Basically, I guess C++ is, from my experience, it can be used anywhere, I guess. That's one of the most popular languages which is involved in lots of many platforms. For example, also for Android Studio, so also C++ is there. And yeah, of course, it's .NET, I guess it's meant in general. Okay, so yeah, two platforms also support other less popular languages, maybe we'll not name them now, but yeah, there's something that for Java framework sets Java as the default language, but for .NET there are three languages can be considered as the main default languages, so that's C#, F#, and Visual Basic Net. And yeah, in this case, that's more flexible approach for developing. Yeah, also, so if you work on Java, .NET, or any other programming or any other platform, then so first we need to need to select the IDE you prefer working on, and for Java, in fact, you can so in this case you need to select them. For Java there are different IDEs used, such maybe the most popular would be SourceTree, Eclipse, of course, DevilJai. For .NET, that's mostly Visual Studio, actually Visual Studio or Visual Studio Code. So DevilJai, Oracle NetBeans, and Oracle GDeveloper. There are different options to select. And some more technical differences. .NET, so the idea of how both platforms you compile the code. So for the input and compile the code. So for .NET, so at the moment .NET project is deployed, then the code itself is deployed, then it's running, and the operating system on which is compiled. So for Java, it works in the way that it's not actually it's converted into binary code mostly, and in fact it's converted to machine language at the moment it is executed. So in this case it takes more time because the conversion should happen, and so from this point of view, C# code is faster and better performer. So just because of the point at which the translation to the machine language happened. Because as I said here during the first presentation, when I talked about compilation, the idea is that for the compilation, actually, so we have some kind of code here as we wrote during the previous sessions. That's C# code or any other language, but the idea is that it's not as simple as we do it, like just simply write the code, then it runs and do some calculation and provides the result. Actually, from the computer perspective, it works because actually the computer only understands it would be zeros and ones, and in fact what happens, actually our code we write in C#, for example, it's translated to more simple language used by the computer, and only after that the logic is executed. And so for modern languages, but we also should consider that some technologies may work differently from the performance perspective, but in our course we will care about this, so don't worry. From the performance point of view, so we should just simply write the code and then execute it. So the target platforms is for Java and .NET. So they both run on Linux and Windows. They can run, but in general, Java was created for Windows. So it has actually it runs fine for Windows as well and for macOS. There are some core things to discuss about how Java works on different operating systems, but originally Java is developed for Linux and .NET, and obviously comes for Microsoft Windows. Then there's such interesting thing I already mentioned is LINQ. So that's the part of the language used for the database operations. In C Sharp, there is such option. We have this integrated language for queries. In Java, there is no such option, and for Java developers, SQL statements should be executed directly. Then there's switch options and strings. Actually, both options. We'll talk about switches, switch statements, and strings a little bit later already today. And yeah, in fact, starting Java 7, there's no difference in their concept. So they normally work. So switch statements normally work strings on both platforms. Keyword for data types. There are some differences how the keywords are named. We'll see that in .NET, in C Sharp, there's shorter keywords. For example, for Java it will be Boolean. For C Sharp it will be bool. But yeah, for example, we'll later on see for integers it's practically be the same. Also, so yeah, from my experience, the main difference Java and .NET is the namings used, and also the names for the variables. We'll see what are the key points for the namings, because again, as I remember I mentioned to you before, for the programming languages, it's very important to stick to the formatting required in exact platform, exact programming language, and it's also, we'll see, it's important to stick to the namings used. Yeah, and we'll see what are the namings for shares some sheets for naming conventions in .NET. You can also easily find them on the internet, Google, about naming conventions, and it's also very important if you work with C Sharp or other programming language. It's very important to think about naming conventions. And there are also generics, such thing. We will talk about generics a little bit later, so for right now maybe you will not understand the concept, and that's why maybe I will not stay here and talk about generics. We'll talk a little bit later about the generics. And some things about basically the overview I discussed on the previous presentation about how .NET is built. So again, as you remember, we have three main parts for .NET, three main actual frameworks. .NET, that's based .NET framework, and that's the actual platform used for applications in Windows. Then there is .NET Core. That's the framework which makes .NET cross-platform. Yeah, it's open source. It's optimized for different needs, and XAML, which is mostly needed for mobile devices, for iOS, Android, and also OS X, which is macOS. And so yeah, that's mono-based runtime. And so these are pretty different. In fact, yeah, so .NET is, so that's kind of traditional framework for .NET, used for Windows. .NET Core, that's cross-platform, so you can run it on different operating systems. You can easily do it. Then XAML, that's for, as I said, for mobile apps. But actually, starting .NET 5, they are all now fused together and simply called .NET we will be working with. So that was basically short overview of the introduction, and right, yeah, so in case you have any questions, then let me know, but right now I would like to finally we can go to the programming part. So basically right now uh, we have done all the preparations needed, and now we can uh, move on with our main topic, which is called programming. Basically, I can call it programming on C#, and basically programming in general. So let's start. You have this presentation. I guess I shared it today. Let me double check to not miss. Yeah, I have this C# basics. Here you should have it under notes and resources. Here, just if anyone missed, you can find the presentations here and under notes and resources. So let's start. So first, what we'll talk about here. So of course we'll see what the variables are, introduction to the variables, the data types used in C#, the ranges of the values we can use for the variables in C#. Then we'll talk about casting operation. Quite interesting, I would say, in all the programming languages, and actually it works in a similar way for all the programming languages. Then about the variable declaration, assignment of the values to the variables, and then about also the initialization of the variables, and again also talk about originals. Yeah, and yeah, as always, you can type the questions anytime during the presentation, as always we do. Okay, so let's start, and here is a little bit, in fact, this comes from statistics, yeah, from my experience. And so yeah, if you study statistics, then you may know the different types of the variables. Yeah, so in general, we can split. Actually, yeah, what are the variables? Yeah, maybe if you never touched the programming, you may not know what the variables are. Actually, this is the theory. We can say that this is the, not in theory, but in fact this is the place in memory where we can store some kind of actual information. And so it can be yeah, so basically that's the place where we can store the information, which and from the programming perspective, we store the information which then to be used during the execution of the programming code. And so that's the place. And yeah, obviously, as I just said, so since this is the place, it can store some kind of information. And from the programming perspective, the information, the type of information can be different. Yeah, so the type of information we can store under the exact variable, it can be different based on what we declare, how we declare this variable. And so first of all, let's take a look on how we can categorize the variables. So normally we can categorize them into quantitative and categorical variables. So for quantitative, these are the values result from counting or measuring something. You can actually do arithmetic operations on them. So this would be a few hertz, which terms continuous and discrete. This mostly comes from statistics and mathematics. But the idea from continuous, it means that the values are they actually are endless, so they're not so they're actually continuous and they're endless without any spaces in between. So it means that if you have like any range of the variables, so any range of values, So it means that actually absolutely all the values inside this range, they can be used for this particular variable. For discrete, it means that actually at the range is not continuous. Like this can be 1, 2, 3, 4, 5, 6, 7. So it means that like if we say it's 1, 2, 3, 4, 5, for example, it means that 0.5 is not included in this range. Yeah, 1.5 is not included, and so on. So it means that this type is not continuous. Actually, from mathematical point of view, it's, yeah, you can see there's variables we name double and float. You'll see that these are decimal types. But from the mathematical point of view, it's also not really correct to say that they are continuous because in programming, actually, yes, there's nothing what we can call continuous, because everything has limited memory, and so in fact also that would be more correct if we say that double, from theory point of view, we can say that double and float, they are also discrete types, but just to easily understand, we can at some point of view say that these two are continuous. But yeah, so if we take a look on them, so double and float, these are decimal types. Decimal types, so it means that it can be, so from a mathematical point of view, again, it means that these are fractions. Yeah, so it can be fractions, and they are written in decimal way. So that would be, for example, 1.23, for example, or 5.78. Or 6.1234567, for example, something like that. Yeah, so these are the variables we call double and float. Yeah. So compared to mathematics, you cannot describe something like square root of 3 there, square root of 2. And so this is not possible for programming. Yeah, for discrete, this will be integer, 1, 2, 3, 4, 5, 6, 7, and so on. And long, this is actually, in fact, this is the integer, which has bigger range larger range than integer. Also, these can be negative values, -1, -2, and so on. Yeah, but the difference is that the range is different for them. Character, yeah, so and yeah, now we go to categorial. That is something that we cannot describe as the numbers. Yeah, and this can be the character. Yeah, so A, B, C, D, G, and so on. So one single character. And the string, which is actually, yeah, from programming point of view, it means this is the sequence of the characters. So it means that you simply combine many different characters. They can be repeated. And this is how you create the string, actually the text. And yeah, this is ordinal data. Yeah, so we can actually size them in some way. And then you have nominal. Yeah, like in this case, nominal and binary. So something you cannot really size yet. So in programming we use Boolean, which is true or false. Yeah, it means that that's also comes from math and from logics. Yeah, so if you studied math before, then you may understand what the main concept of that variables. If you have not studied, don't worry. So it won't go too much in theory, too much in math. Yeah, but some concepts from mathematical logics will be included in the learning of the programming, and some concepts are needed here. So we will see, but nothing complicated. Yeah. So and now let's move on Talking about the variables in C#, so that's the name which actually gives the location to the memory. Yeah, as I said, we define some kind of name, and then this name is assigned to the not name, but we should create the variable. Then it's assigned to the specific location inside the memory, and yeah, so we should have the type, a specific type. Yeah, it should be one unique type. Yeah, it cannot be, for example, integer and boolean same at once. Yeah, so it should be integer, for example, or boolean. We'll see what are the objects, in fact, but that's maybe a little bit more complicated topic. We'll talk about it. Wait, yeah, for now, we should know that the variable should have the exact type. Then we go to the declaration. Yeah, it's obviously then, yeah, the code goes from top to bottom. Yeah, if you write the code and if you read the code, as you would already understand, we go from top. So we have one line, and we have, let's say, another line of code, and we go from top from top down, then to bottom. And it means that for code, all the operations are executed one by one. And so we start from here, the first operation, then we go next, the next operation, execute. And the idea is that if you declare the variable, it's obviously then you can only use it after that. Yeah, you cannot use it before you declare it. That makes sense. So you cannot even, you can write, but of course it will prevent you from writing such things, because again, the variable is not declared. So if it's obvious, then you cannot use it before, only after that. Right, so that's about the declaration. First, we need to declare the variable. We'll see different options how you can declare the variable. The variable, and yeah, actually the variable where it can be declared. We will see some different options there. And yeah, so let's move on. And to perform the operation on the variables, so we need to define the variable, this particular type, and yeah, so then you need to specify the type of data that variable hold in your application. So that's pretty much makes sense. I hope if you have any questions about the declaration, please let me know. Also, yeah, for the variables, variables are nothing but name, just name given to data value. So it means that it's shown here. You declare the variable, so you have name, then this name is reserved inside the code. We will see and talk about where this variable is used, when it can be used, and where it is visible, where it's not visible inside the code. So we will talk about this, but the main idea is that if we declare the variable, if we talk about the area that this variable is visible, it can be used and is declared. Then inside this area, we'll talk about these areas where it can be, but for now, we just talk about this particular area where it can be used. So inside this area, the variable is declared, it has the name, and the name can only be used as this variable, yeah, and nothing else. Yeah, so variables can hold the value of particular data types, as I just said, integer, string, float, objects, and so on. Yeah, the declaration and initialization of variables are separate statements. Yeah, so in fact they can be written in one line, but in fact these are two different statements. Variables can be defined by multiple separated by comma, and also in semicolon multiple y until the end of semicolon. We will later on have these examples, but the idea is that yeah, of course we cannot do it this way, because we don't have the if we declare it this way, we cannot also do it. But if we say that, yeah, we'll see what var means. But yeah, so if we use var, we cannot declare with different types. But if we have integer, then we can declare inside one row and separate them by comma. So it means that they both are declared as integers, variable and test in these two variables, and they both are integers with the values assigned. You can also skip assigning the value, but in this case you have a compiler problem. That's because that's because it was not initialized. We'll later on talk about it. But the key point here is that you can declare the variables, multiple variables inside one line by providing the type. And you can also initialize them during the at the same line as they are declared. Right? So variables must be assigned to variable before we make use of it. Yeah, so this is what I had here. So I tried, we'll talk about the separation a little bit later, but it means that we add 3 to this particular variable and assign it to it. In this case, since the variable is not initialized before, this will be considered as compilation error. But if I assign it here, this way, or this way, or this way, then it should not be considered as the issue anymore. Yeah, so first of all, if you do any operations with the variable, then you first need to assign the value to it. First point, and the semicolon. Yeah, so we'll talk about how the code is constructed. But so this homework help section, I already mentioned that the code is split into different sections. Yeah, so it will be mentioned, but from my point of view, this is one of the first things to mention to you. And so what we should see, maybe shortly about the structure of the code. Later on, I guess there will be part of the presentation, but so this is important before we actually think about any coding. Yeah, so first of all, we have this using the system. It means that the system parameter, system classes, system objects will be used inside the code. That's one thing. So this is what we declare on the top. We separate so all the usings in semicolon and nothing more here. After that, we go to namespace. So we declare the namespace. This is the identifier of this part of code. And it can be, we will later on may reuse this part of code from somewhere. So and then we put our namespace, then name, then we start the block. Yeah, so you can see we use curly brackets to start and to end the block. Yeah, so using the blocks, we will later on talk about where and when we can use the blocks, how the what's the visibility for the variables declared inside the block. Yeah, what are the key differences there? But yeah, the key point is, so first point, what's to know is that, of course, obviously the block is opened, then it should be closed at some point. Right. So you can see that for all the blocks, they are closed at some point. And it also means that, so where you close it, it means that everything what is inside this block is considered as the part of this block. So you, as I understand you cannot do it this way. In theory, if you can, but in this case, the code will be incorrect because the class should be the part of the namespace, and in this case, of course, we need to have this block and on the block here. So because the class should be part of namespace, that's the first thing. So then we go to class. So this also is the block, the block of which contains the content of the class, all the main definitions, all the main methods, and the attributes of the class. So all the things will be included inside. So again, we start the block and we finish the block. Then for the method, also void, we start the block and we finish the block. So that's about the blocks. So usually, not usually, but we use the blocks when we need to put some content, some statements, some section inside. So we'll see where we can use it a little bit later, but it means that some parts of the code will be located inside. And then we also have semicolons, and for some students, for the beginners, this may be a little bit confusing where the sections and the blocks are used and where you can just simply finish the statement using the semicolon. And actually the answer is quite simple. Semicolon is used when we execute some kind of statement. If it's declaration like this, it should be closed with semicolon, because otherwise the program will not understand where the declaration is finished. So with semicolon, we see that the declaration, the operation which declares the variables, is finished at this point. Then here we have the assignment. We assign 2 to the variable. At this point, we also have this operation. We say to the program, please assign value 2 to the variable, which is named variable. And maybe just to make it confusing, let's say that the variable name is variable name. So then we say that we simply assign 2 to the variable. And so in this case also the operation is finished, and we finish it with semicolon. The same as next time, and we see that we add 3 to the variable. So then we also close this operation again. So simple thing. We just simply use semicolon to finish the statement, finish the execution. Alright, so if you have any questions so far, please let me know. Then if we go to the values, they should be assigned before we make use of it, of the variable. That's what I just shown. Then the value of the variable can be changed at any time after the program accessibility. So about the changing, that's true, but there may be some restrictions of the visibility for the variable. So in this case, we'll later on see about the scope of the variables, but the key point is if we declare the variable inside the section, we cannot it cannot be visible from outside the section. And so for example, in theory, if we create another method, like in this case, so from here we cannot access, so we have this section is closed, and so it means that inside this section variable will not be available, and because it's declared inside this section and it's not visible outside this section. So that's about the variable. We'll later on talk about the scope of the visibility for the variables, but yeah, you should also know that there are the cases where the variable cannot be used. Right, the next thing is the data types. We already started talking about them, and basically what are the key, from technical point of view, what are the key differences of the data types. Each data type has a limited size. This is what I said, and this is why computer science not computer science, but programming will never be the 100%, will never reach the math, because in fucking programming everything is limited, yeah. So we cannot have the, like, for the numbers, the set of numbers, it cannot be endless. Yeah, so same for the data type of the variable, it has its size, so it is limited. And it also has a specific type. But yeah, on the core level, on the programming, on the machine level, computer level, the type is defined by zeros and ones. Yeah, from our point, we just think about data type, and also the point is that the different data types using different size of all the storage. Yeah. So that's also the point from the computer perspective. So the size, in fact, may be different, and that's why sometimes there may be different limitations. We'll take a look at them a little bit later. And yeah, it's also important to use the correct data type for the corresponding variable. That makes sense. In theory, you can consider, yes, you may maybe right now think about that the numbers can be considered as the texts. So maybe from your point of view, you would say why we just simply can't use the text for all the numbers. The problem is that for the texts there are different operations defined. Yeah, and also the different memory requirements and programming. So if we know that we work with the texts, with the numbers, then we don't use string, boolean, or anything else. So we use only the data types which are needed for the numbers. And because of the operations defined for them, yeah, obviously because of the programming code from the external libraries, not only external libraries, but also from the system libraries used, so they require the exact data type. Yeah, so, for example, we use this console write line. Yeah, we can see that it requires a string. Yeah. So it requires string. Actually, yeah, there are 17 overloads. We'll talk about overloading a little bit later, but in this case we know that it uses text. It uses string. In fact, it can use 17 different patterns. But we can think about that if we use something not written by us, and that's the system written by system. Then of course the requirements for data type may be specific, and that's why we should select the right one. Yep. So that's about data types, and so maybe right now let's have 10 minutes break, and after that we'll move to the we'll talk about data types in more details. So let's have 10 minutes break.
Так, опа, вышли на улицу, там они сколько.
Okay, let's continue. So, and now we are talking about the data in the system. So this is the actual data we can store. And so in this case, we can talk about if it's programming or not programming, if it's the database, or basically that's actually the place where you can store the information. Yeah, and typical examples, as I said, if you're working with programming or database or also Microsoft as well. So if you work with Excel, then you should also understand you have different types of the cells. Yeah. So I mean the types, data types for your cells. Okay? That's currency. It can be currency. It can be number, date, whatever it can be. What else it can be? Yeah. So the same as basically for all the places where we store the data in some way. And yeah. So now since we now talk about the programming, then so let's say that we have four different elements, four different parameters, and this is the name, the parameter name. So let's say we just simply need to store the information about the person. So what the person has? The person has the name. So we say that this is the parameter of the person, and the value for this particular parameter is John, and that's the name. Makes sense? Then the age, so yeah, the John, and what's the type of John? The type of John, the type of this value. That's text, that's string, yeah. Because we have the sequence of characters. So yeah, the sequence is J uppercase, then O uppercase, H overcase, and N also overcase. That's the sequence of characters, so that's the text. From a programming perspective, that's the string. Then we go to age, yeah, also the parameter, that's the number. So since the age can only be integer number, so it means that this is int, or in theory we cannot, but yeah, so we can also say that it can be long. And in fact, if we are more precise, then this would be unsigned. The integer number, because the number cannot be negative. Yeah, it can only be positive. So yeah, that's the type, integer type. Then we go to gender. In fact, we can also say if it's, for example, male or female, then we can put the value true or false. If it's, for example, say male, yeah, then we say, in this case, we say true. Yeah. If we say female, then if we have the parameter female, so true or false, then in this case it's male, we say that's false. Yeah. So from this point of view, we can describe the variable as true or false, the value, the parameter of the person as true or false. But in this case, we describe using the character, so that's char. Yeah, but also we can, like in such case, where we have only two genders. Of course, there can be maybe some kind of another gender, more genders. Then yeah, okay. Then in this case, we can say that this is character, yeah, male, female, or unknown, or something else. Yeah. Doesn't matter. So in this case, that's character, one character, and nothing more. And the height, yeah, then this should be the number with decimal digits. Yeah, so in this case it's 1.87. So that's the number with the floating points. With the floating digits. So this can be used, such system can be used in programming, also in any data storage. And yeah, this is what I said. Gender has one symbol, age and height are numerical, they're floating, there are decimal numbers, and yeah, name, text is set of symbols. And yeah, each data type consists of specific parameters and operations. So it means that, for example, maybe I can do it directly from the code. Well, this will not be the problem. Yeah, for example, let's declare two variables. Yeah, we have two variables, variable name and test. They both are integers. Let's assign some kind of value to test. Then we say, let's declare maybe another variable. This out, and this will be variable name plus test. Yeah. So in this case, we just simply have the sum operation, and so we add the value from test variable to the value from variable name. We sum them, and then we get the result. So that's for the integers. Okay, maybe don't confuse you. Let's do it this way. I will use integer. And so in this case, we have the operation. It can be plus, it can also be minus, division, multiplication, and so on. We'll talk about operations a little bit later. But yeah, we should know that for different variables, the operations can be different. So, for example, for string, define two parts. and let's get the result. String. Then we used the sum operation, but just to make it more understandable, let's print the result, and later on let's also print the result for the sum operation, and then let's also print the result for the concatenation of the strings. So when we use plus for integers, when we use the plus for strings. And again, I'll use terminal. I will. That's well for that. Okay, maybe. Maybe let's use new one. And as I promised, I will create a new folder. Maybe that. Actually, I guess I can simply use git under this folder. The whole folder with you later on. So maybe let me create new. Yeah, maybe I'll name it data types, or maybe let's say intro, maybe basics example. Okay, so now let's select this. To resize it. So let's select this folder. Select it. Right now. Here we go. And yeah, so let me create the file. That would be data types outnamed. Data types. And then I'll copy something from here. I'll copy all and then do some changes. So that would be, select my namespace, that would be basics. Then I will select the class name. Let's name it as data types. And so I guess maybe let's not call this one. So now we are here, and let's see the result. So first of all, as before, I will use mono compiler. I will compile this class data types.cs. It is compiled now. Now let's execute it. Exe. So what we see that we have two prints. Yeah, so this part is printed from here, and this part is printed from here. And what we see here, we see that here we provide the result of some operation using two integers. So it's oh yeah, maybe about this operation is confusing, so maybe let's not use it at this point. And I will comment it out, or I will delete it. Just to not confuse you, I will talk about what this means. Yeah, but actually I said already, so for you it's if it's confusing, we'll discuss it later on. Yeah, it means that we just add 3 to the current value of the variable. So in this case, that would be at this point variable name has value 2, but if we use this operation, so it means that the value for the variable name for this variable will be 2 plus 3 will be 5. Yeah? So that's why here we, at this point, variable name is 5 and test is 4, so 5 plus 4 is 9, and this is the result we get here. Yeah, and for string operation, for string, we can see that we have two strings, part 1 and part 2, and we use plus. And for this part, yeah, that's a crazy thing, because not crazy, but it may look a little bit crazy because here plus works as the mathematical operation, here it simply works as the concatenation of the strings. And so this is what we need to know, that for different types there are different operations allowed. Yeah. Also we will see that in C# all the data types are actually objects, and then we will also do some operations from them. We will be able to do some operations when we consider them as the objects, but this is maybe a more advanced topic for now. We will talk later about it. Yeah, so here you can see it's not possible to do summation with ages. It's possible, yeah, of course, but not with gender. Yeah, you cannot. Yeah, that's in theory. In fact, let's quickly check. We define two character variables. So this would be male and equals to m, and female equals to f. And let's try to string both genders. Let's add male to female for characters. That actually works, yeah, for characters. That works for characters. And I guess, yeah, we can also print the result. So let me repeat these operations. No, yeah, that's the compilation error. Yeah, so now you can see the compilation error, and so it shows. Okay, it does not show the one, but it says cannot convert. Yeah, so that's because of this one. Yeah, I'm not sure why, but ID does not show us this error, and yeah, basically that's because of this part. Yeah, this is part. I said we cannot simply concatenate two characters. If you, oh no, hold on. I guess here is an issue. Let's double check. Let's double check now. Okay, now we have one error. It's interesting. It shows me cannot convert integer to string. Okay, yeah, I got it. And this is more technical thing. Maybe what's not really. Characters are also in front of you in some way. They're considered as integers. So in fact, what will we have here? They're stored as numbers, as integers. So I guess, yeah, if we do it this way, then this should work. Yeah, so now we see that the program is compiled, and that's actually, from technical point of view, quite interesting thing. Because actually we can work with the characters as with the integers. That's, yeah, maybe let's not focus on it now. That's just one interesting thing, that it simply can convert character. It can consider also characters as the integers. And in fact, if we do the sum operation for the characters, you can see here, then result will be also the integer. That's maybe more technical thing, just for your information. Yeah, it is also possible to change name letters to capital, but it's not possible to do this operation with hyphen. So That's yeah, and that's what is asked by Vlad. This is what I said. When from programming point of view, from C# point of view, if you do the sum operation using the characters, so in this case you can see that I use characters, I don't use strings, so these are not strings, these are characters, and each character has its own integer number assigned. So for example, guess we can do it male num, and I guess we can try it this way. Yeah, so it works as well. So in fact, I can declare actually character as the integer, but what we will see at the result. Okay, let's do the same for female. Yes, so actually we can assign integer to character. Yes, we can. Should be compiled. So maybe let's do this then this way. So I will print the code formatting stop working for me some way. That's interesting. Okay, let's try to format it in the right way, and let's try to compile it because that should be compiled. Yeah, so it is compiled without any errors, and we'll see that. So actually, character 77 equals character M equals to 77. And we can also see that female F character equals to 770. That's why we have 147 at the result. Yeah, actually, this is called typecasting. We'll talk about it a little bit later in this presentation, but the key point is that characters from the programming point of view, they're considered as integer numbers, and then we can simply pass character to integer and get its unique integer number assigned to this particular character. Yeah, so for M it's 77, for F it's 70, and it also works in the opposite way. So 1 moment. So if we say that it's male from integer, then I guess we can also pass it this way, and then do it the same for female from integer, then it should be 70. Okay. And then let's print these two characters, and same here. This is called typecasting actually. Just compile it, and okay, in this case it does not allow it. Okay, then I will later on show you that we can try to use this operation. Let's try again. That's maybe not what you need to do. Yeah, so now it works. This is called casting. I will show you later what does it mean. But yeah, for such things like characters, maybe this is not what we usually do. So here. No. What we usually do every day, so that's just for your information that characters are considered. Yeah, so what you can see, that we can convert 77 to character, and this will be M. If we convert 70 to character, this would be F. So it means that there is the unique mapping between the characters and the integers. Yeah, so for each character, actually we have one unique integer, and that's why it results 147, because it just simply counts 77 plus 70. Okay, the question from Wayne. Yeah, that's a good question. To initialize string, we use double quotes. That's correct. To initialize characters, single quotes. Yeah, that's correct. Yes, but actually in C sharp, let's maybe double check. So yeah, for characters, we normally use one single quotation marks. Guess doubles will not work in this case. You should use single. Yeah, only single for characters. Double are used for strings. Yeah, actually I was a little bit confused because it did not show the error, but yeah, of course the program is not compiled because this is considered as string. Yeah, so this is the string and this is the character. Yeah, that's correct. We use single for characters and double for strings. Alright, yeah, maybe a little bit confusing for the first time, but that's not the key point. The key point here is that we can use different operations with different types of variables. And characters, just additional information for you, characters are actually considered as they can be converted to integers, and we'll see when we talk about casting operations. Okay, so let's move on. Let's move on. So then we have such term like primitive data type, which is maybe not so relevant. This term primitive data type is not so relevant for C#. It is more relevant for Java language. But so yeah, if we talk about primitive data types, then this is actually the simple. Yeah, we can consider from the easiest. From a simple point of view, we can consider the primitive data type as some kind of simple type, yeah, which is not advanced type. We'll later on talk about what are the advanced types can be created and used in C#. But so if we have something really generic, like we just use integer character, then it's called primitive type. And for primitive type, yeah, we can see the most popular integer, object, short, character, float, double, jar, ball. We'll talk about objects a little bit later. And yeah, they're called primitive data because they actually built-in types. And could be used to build, so using them we can build other data types. So for example, numerical data types are whole numbers without any fractions, and yeah, then we have numbers with fractions or comma. These are float and double. And yeah, so now we can take a look on the list of built-in data types. So these are byte, integer, and so on. Yeah, so these are built-in, and actually comparing to Java, yeah, so here is also from my point of view, the key difference between C# and Java. Then in C# all the data types are objects. And so from Java point of view, in C# we do not have any primitive types, we only have reference types. Because yeah, in C# all the types are objects. And they all come from the system namespace, and that's why we always use system namespace here. Because otherwise, so let's comment it and see that nothing should be compiled here. Yeah. Because now the program does not understand what are all these types. Yeah. And what's the console is built, that also comes from the system. That's why we use this using system. We need to include these data types, and then we can use them only after that. Yeah, for each data type, short name is provided. Yeah, so we use short names only, not only, but mostly. For integer, that would be int 32, and for double, we can use this double in uppercase letter, starting with uppercase letter, capital letter. So in theory, we could use, so let's check the list. So for string, that will be string this one. And so in theory, we could use this string, and I guess that should normally work as well. So we'll check. Okay, now everything is compiled, then this will actually work the same way. And so everything will be the same if we use string instead of string, but what's the point? The point why we use and we will use such short names, that's because, so first we need to distinguish these primitive types and the more complex types. That's first, and yeah, that's basically that's that's the main point. So we need to distinguish them this way. Yeah? So that's why we use short names, and to not confuse others with long names. So they will be used for other purposes. I mean, long names in general. Yeah, so this is what you can see, and actually we can say string as this string, or we can also say system string. So system the string. This should be the same. Compile, yeah, you can see that everything is compiled. And can be run, so everything will be the same. Yeah. So this is equivalent approach. Yeah, we just use the shorter way. We don't use system because system is already included here, and instead of string we use this short, small string, simple string name. But in fact, no difference from the practical point of view. And this is what we say. What we see here. We see John. That's the string. Then 18. That's integer. We can also go shorter. So we can go shorter and say that this is byte. Actually, byte, it's also assigned integer from 0 to, yeah, you can also see, yeah, this is what I said. Before that, all the data types have, in fact, yeah, they have some kind of limitations. If we talk about numbers mostly, yeah, numbers have the limitations. Yeah, for example, the smallest is byte. It goes from 0 to 255. And then we have integer and all the other types. Yeah, if you need to do something long, then this should be double. Yeah, with this number, yeah, so that means it's 1.7797 and so on times 10 in power of 308. Yeah, so it's quite large number for double. If you use them, and yeah, but please note that for double, also the decimal points are included here. Not just simply integer part, but the whole double is considered as one value, and the characters are also counted there. Yeah, but also what you can see for string, we don't have the limitation. We don't have the limitation, and this is what I said. String is actually not the simple type. It's yeah, again, from Java point, it maybe looks a little bit more precisely, because in Java, string is not considered, as I mentioned, string is not considered as the primitive type. And but yeah, from the technical point of view, strings are the same in Java and .NET. And string is, as I said, that's the sequence of the characters. Yeah, so it's not just like something similar. It's simple. Yeah, it contains other data type. Yeah, in this case, that's char character, and also integer can be. Yeah, so that's the sequence of the character. And in fact, this sequence can be endless because from the technical point of view, the sequence is stored in an interesting way. And in fact, it has no limitations as numbers have. And so that's why for string, as my colleague said once, we can actually write the book inside the string. Yeah, that's also possible. One book right there. All right. And let's move on to the integral value data types. And the integral numeric types, they represent integer numbers. Yeah, so they are value types, and they are also simple types, and they can be initialized with rows. Yeah, this is what we already did today. And all integral numeric types, they support arithmetics. Yeah, we can use plus operation, minus, so sums, then multiplication, division. Also, there's some bitewise logical operation, comparison operation. We will see how they actually work. And yeah, equality operation to check if one number is larger or smaller than another one, and that's also possible. Okay, and yeah, so these are the integral integer value data types. And so that's s byte, small byte, yeah. Signed integer means that it has negative values, and it also has positive values, and byte the same but without the negative values. Short, small integer, and u short, that's unsigned integer. Integer, uni, it's unsigned integer, long and unsigned long. So nothing special. We mostly, at least I mostly use integer. That's the most simple type to use, and for me it's usually quite enough to use it. And then we talk about reference data types, and in this case, in fact, but yeah, okay. Yeah, in this case, reference data types is something which is built using other data types. And what I said, this is what I said about string. Yeah, string is actually the reference data type, and yeah, so as I said, that's the sequence of the characters. And how does it actually work? So you have the variable. So in this case, that's the variable, and basically how all the reference data types work, not only for strings, but for all the reference types. We call them objects. Mostly we call them objects. So we have variable, and then we have the address of the variable. The address points us to the place in the memory. Yeah, so that's address which shows us the place in the memory where our variable, where the value for our variable is actually stored. So in fact, what happens if we have the variable? Yeah, the variable actually does not store the value. This is what I said. Why string can have unlimited number of characters. The idea is, again, as I said, quite simple. Because string itself, it does not store the string variable itself. It does not store the characters of the string. It stores the address to these characters, to the sequence. Yeah, so it has the address, and the address actually points us to the memory where the sequence is stored. So as example, and here we may see some interesting properties. So let's maybe, I will maybe create a new class. So yeah, I will copy the basic B, and let's name it as string examples. Call it section. And what's the query string? String test string A, B, again I will use part 1, and then test. And so now we have two strings, and what actually happens? The string, it does not store actually this value right now, it stores the path to this value inside the memory. And in C#, the strings are, later on see them, they are not mutable. Yeah, so it means that when we, basically what happens, when we create a new string, so that would be new, for example, and let's say we concatenate these two variables, then what happens actually in this case, or maybe we can also say this way, so it means that string A equals string A plus string B. In this case actually new reference is created and new string is built. That's also one important thing, because the arithmetics and not arithmetics, basically all the operations with strings, they do not work the same way as they work with the numbers, simple primitive numbers. And that's because string has reference, special reference type. And in this case, again, as I said, once we create string here, it has the reference to the memory. And in this case, it also has the reference to the memory where the sequence of characters. So in this case, for string A, the sequence is PA RT1, then for string B, the sequence is PART2. And what happens in this case? In this case, it's not just simply the concatenation of the strings. We actually create a new string here. Yeah. So that's the difference, and we'll later on. Okay, maybe I can quickly show you one thing. So as you know, we can compare the. No, I do not. Maybe let's talk about the Boolean, about comparison a little bit later, and then we will also see that there are some interesting, a little bit strange thing happen with the strings. Yeah. So and this is what you can see here for numbers. So these are integral data types, and for string, that's the reference. And why? Because yeah, actually there's we didn't talk about arrays yet, but yeah, in fact the string is built using the array, so that's the sequence of the characters, and the way it is stored is significantly different than the way how the integral variables are stored. Yeah, so the variables in general, once the variable is created and used, then the area memory, then they're placed in RAM memory, and yeah, so the question is how to get specific data or data set from the memory. This is what we do with the variables, and it's necessary to set the name, of course, to identify it. Otherwise, how can we identify? How can we ask the memory for the corresponding waves. We should have the identifier, and then that's why we use the names. And yeah, so how variable declaration happens, as you seen before, we have the data type that's on the website, and after the data type is provided, we provide the name of the variable. That's how it happens, and data type that's selected type, if I said, can be, so for example, as we talked today, integer, string, double float, and so on. In fact, there can be more, of course, and more types. We'll talk about other types, and mostly these are the classes. We'll talk about them a little bit later, especially in object-oriented programming. But yeah, that's the point. On the left side, we'll have the data type. On the right side, we have the variable name. Yeah, so that is how it looks like. For float price, means that the price is the variable which has the type float. Same for others. XAML, that's character. So, and yeah, boolean. Yeah, maybe let's have a small example with boolean. So let's maybe define it at the end. Bool, so test. Bool, and it can be true or false. So then we can also print it. Then it obviously will be true in this case, and it will print true. I'm not sure whether what I call formatter is not working for me. I'll maybe check it after the session. For now, I guess it should not be the issue. So let's compile it. And then let's take it. And so, okay, now it's true with the uppercase. But that's capital letter, but that's not so important. What we can also, okay, maybe I'll show it a bit later, or maybe right now. So we can also have this comparison operation. So a little bit later, but actually it checks if this variable equals false, and then it returns true or false if the statement is correct. In this case, the statement will not be correct because test bool is true, and true not equals false. And that's why the result will be false, because true not equals false. So we'll talk about comparison. It's just a small introduction to data types. Yes. Yeah. Sounds false because true does not equals to false. So we can do the comparison. Interesting thing, what we can see is, and I can maybe show you right now, and then later on I'll explain. So let's compare two integers. So we have two integers, integer variable name and integer test. So let's execute it. Data types.cs, and then data types.sem. You can see that 5 is not equal to 4. So if we assign a new variable here, a new value here, say that test equals 5, at this point obviously 5 equals to 5, and this should produce true. It's one way what I can do. I can, so to not repeat these commands several times, I have one way how we can escape this, so I just written the comments in Notepad, and right now I can paste them both and execute them. It takes time, of course. Yes, and I can see that that's true because 5 equals to 5. Yes, so for when we work with the primitive types, we can simply use this compare operation. If we work with the strings, this will work in the strange way. And we will see why. So maybe first of all, let's do the following thing. So we assign part 1 and part 1 to both strings. And let's see how the right line result will look like if we compare two strings in this case. In this case, that should produce true. Okay, let me also add these two comments. In my notepad, and then I will execute them in console. Okay, so sorry. Okay, in this case, sorry, need to comment out. So that's the comment. It means that this code will not be executed. Yeah. If I use comment, then you can use the shortcut Ctrl-L for this purpose. But now you can see it's true because part 1 equals part 1. That's obviously. If we compare part with part 1, now it should be false because it's obviously that part 1 is not the same as part is not the same as part 1. So this makes sense, yeah. If we compare these two, then the result will be false. That's obviously. But for the strings, there's one tricky point. So right now, if I add 1 to part 1, let's then execute them. Okay, now it is true. Okay, now it's true because we one moment. Now let's maybe do it this one. Test add. Let's try again. And now let's add string. Okay, that's okay. Then in this case, that's fine. But what I want to say is that for strings, so we will later on see why. But for strings, we should use different way to compare. And so in this case, we should say equals. We should use equals, and then this way. What's the point of bool? Okay, yeah. So that's the question from last night. I will explain this. Okay, so I need to implement. Okay, then we'll talk about this equals a little bit later. For now, let's we keep it as is. Yeah, the question was what's the point of Boolean? The point for Boolean is to store, basically for Boolean as the variable type itself, the point is to store true or false. And just to store if it's true or false. That's, yeah, basically, if you ask what's the point of bool type, so that's it. It basically stores true or false. It has two values, value true and value false. If you ask about the comparison, then actually this is the operation, the same as we have the operation here. We sum, we add test value to the variable, main variable, then it produces the result, and the result is another value, which is the result of this operation. If we compare two different values, then the result is true or false. Yeah, so it results into the Boolean value. So in theory, we can say that this is bool, compare results, and then we can also do the same way here. So I assign the results here, and this should have the result, and then it stores true or false. Oh no, this one? Sorry, this one. So result will be the same. Actually, this the same way as here. If we sum, it produces the value result. Here, if we compare, it produces the result true or false. So if we use double, so these are two different operations. This is assignment operation, which assigns the value from the right side to the left side, to the from the value from the right side to the variable on the left side. This is the, if we use double equals signs, then it means that we compare two variables, yeah? And it results true or false, and it also assigns it to the left side. Now this is how the Boolean is used. Yeah? It results true or false. But where we use it in the logical operations. Yeah? So in this case we just only use equals. There is also not equals, and there is also greater or less than. These are all used in logical operations, and they return the Boolean result true or false. So is it more clear? We will have more examples a little bit later, but before the beginning, is it more clear? So that's the data type. So from basics, that's just simply the data type, which stores true or false, the same as it's done for the integers. Yeah, integers may store 1 to 3 to 5, and so on. Boolean store only true or false. Integers can be used to, let's say, to count something, yeah, to do some mathematical operations. Boolean is used to do the logical operations. Yeah, mostly we compare something, we check something, if something is true or false. Yeah, so let's say that, for example, today is Wednesday. Is it true? No, it's false. Then the result of this, yeah, basically. So here you can imagine, yeah, really nice thing from the nice example from the real life, not from the programming. Let's say that we have the statement which checks today is Wednesday. That's false. So that's the result of this check, you know, what I just said. The check is today is Wednesday, that's false. So the result is false. Today is Tuesday, that's true, the result is true. Yeah, so we can also store this result somewhere. And this can be a Boolean operation. The same, we can also have such check like today, so the day of the month today is greater than 5. That's true. So we have this result true, it can be stored somewhere if needed or shown somewhere. Then we can say today, the day of the day of this month today is less than 10. That's false. We can store this value also somewhere. It returns true or false. Yeah. So that's as the example. You can say any statement you want. You can say that you can ask if this color is black. Is it black? No. That's I guess that's blue or light blue or not a specialist in colors. Yeah. So that's we ask if this color is black. No, it's not black. So it returns false. That's the operation. Yeah. So all the logical checks we can do, and this is how the mathematical logic works, and also how the Boolean values work. Just simply check if something is true or false. But yeah, this is very powerful way, and it is used in all the levels in programming. Yeah. So Booleans are quite powerful, especially if we talk about the logics. Yeah, it's used in simple programming. It's simple programming, but in such way of programming we write here, it's also used in the database. Yeah, so if you work on the database, maybe let me show a quick example of SQL statements. Okay, let's maybe take a quick look on the SQL statements. So that's not the simple programming languages. That's simple. I mean, this is not the programming language which we use now, but that's the query language. So if you work on the programming, you'll definitely face some SQL queries, and so for example, it works so slowly. I have one example here. Let's see it, but okay. So here it is. So for example, it says that select me something from the database where and reported equals true. Yeah, so it means that, and this is also the logical operation, reported equals true. So it means that all the entries I select from the database, they should have this parameter, reported equals true. And actually for all the parameters it checks, for all the rows in the database it checks if it's true or false. Yeah. So I go to one row, check is the value for the field reported true, and if it's true, then this is valid entry. If it's not, then it's not valid. And so basically what I wanted to show is this SQL statement. Yeah, maybe we'll talk about SQL a little bit later, but yeah, what I want to show that the logical operations are used everywhere. They're used everywhere, and this is why we need Boolean. Yeah, we'll later on see some interesting things we can achieve using the Booleans, using the logical statements, and sometimes it can be a little bit tricky, but also it's always very useful and very powerful tool. But okay, right now let's maybe have 10 minutes break, and after that we will move on. Okay, let's move on. So first of all, the strings, yeah, maybe forget what I said. For strings, yeah, everything should be fine. You can use this comparison. In some cases, there may be, but no, I guess there shouldn't be any trig points. So, in fact, you can use comparison for the strings in C# as well. There's also equals operation. Okay, equals operation. I guess this should normally work in this case as well, but it actually will be the same. So if you have warning during compilation, that's fine. Yeah, that's all true. Yeah, so for strings, usually you will see that equals is used, not comparison simply this way. And that's because that mostly comes from Java. Because in Java, in fact, you will, if you, in some case you work in Java, then you will see that in Java you should only use equals. For strings, you cannot use comparison, double comparison. Equals mark as used in C#, as used for numbers. Yeah, so that's just one small remark for strings. We use equals. But okay, the question from Win regarding data types, how to know which data type to use for numbers. For numbers, there is, so first of all, we need to know if you need to have decimal number or integer number. If the number is integer, then again, mostly it depends. If you know that you work with small number, so let's say that's something very small, then you can use sbyte. I usually use integer, and so during this course you will see that I mostly use integers for the numbers, and if you use integer for integer numbers, that's fine. If you don't use decimals, then I mostly use integer. That's the simple choice, but of course you may also use byte if the range is smaller. But again, the decision is smaller. But again, the decision is up to you. If you work with large numbers, then you can find something. Then you can use long or also unsigned long for integer numbers. But usually integer is fine option. So see, Elena shared the link here. So here you can, so this is also, you'll see here the explanation. But yeah, actually, so here you can see the range used for the integral numbers, and the same, I guess, you'll find under this link. So also you'll find the ranges. So it depends. It depends what you want to use, what you want to achieve. But so I usually use simply integer, and that's the simple. It's always the simple choice. But of course, that depends on what you want to achieve. What's the range of the values stored for your variable? That depends, and there is no strict rule what to select. But of course, if the range is larger, then you cannot use bytes. Practice, so that's about data type code optimization. And this is what I said. You can declare the variables in separate rows, in separate statements, but in fact you can also declare them using one statement, one row. So it says that in declares grade 1, grade 2, grade 3 variables, and they all are bytes. That's the shortest, the short option for this code. In fact, it does the same, just a small optimized version. You can also assign the values directly inside if you want. This is what I said. It's also possible to assign the value directly during the initialization, and also so you can assign the value. And what I said, this operation, so this is also the operation which assigns the value from the right side to the variable on the left side. Please do not mix them with double equals sign. That's because that is comparison, returns true or false. the operation, dual operation. This operation assigns the right side to the left side. And yeah, so these are the examples that we can assign. Yeah, and it's not possible to do an assignment before declaration. And this is what I said. You cannot use the variable before it is declared. Yeah, go from up to down, and of course, and the logic simply again I said goes from up to down. And that's why you cannot start with some kind of usage of the variable before it is declared. It's quite obvious thing, I guess, right? So first we declare the variable, and only after that we can use, otherwise it won't be visible. Yeah, it's possible to do a declaration assignment in the same code line. Yeah, this is what I said during the initialization. Provide the type, variable name, then directly the value, and that's just a shorter way you can do. You can declare it. You can assign inside the code, you can assign during the declaration. That's just the short way how the value can be assigned. And then, yeah, here we go to the casting operation, and this is what I already did today. So this example, for example, this operation is called casting. Yeah, so it means that I go from one type to another type in general. Okay, it means, so for example, in this case I go from integer to character. It's possible, yeah, and it simply converts integer to the character. Also the opposite way, what happens here, it converts character to integer. This is called casting operation. The same can be done for multiple different types in C#. For example, this can be if you, let's say you want to convert double to, or maybe integer to double. That's fine, you simply have the variable typed as integer, and you want to pass the value from it to double. Why not? So in theory, double should accept the integer value, and this pretty much makes sense, yeah. So simply pass integer to double, that's possible. That's also called the casting operation. Yeah. You can also do the opposite, the opposite direction. So let's maybe try to do it. So let's declare integer, no, maybe let's start with double. So let's say we have double, and and let's say that this is 2.35. Code converter is not working, code pointer does not work. I'll check it after the session. Yeah, so now we have this double here, and let's say that we want to pass it to integer. So we can save, and let's see. Yeah, maybe let's also print it at the end. Let's see what happens after that. Okay. Yeah, this is what I said. You need to provide casting operation. If you do it this way, so let's start with the simple option, and no, let's start with let's start with integer. So main int, something like that. So when I declare integer, I assign the value 33. Then I want to assign double from int, and here I can assign integer. So at this point you will see that everything will be fine. It will turn it automatically without any complaints. I'll comment this code for now. So, and let's compile and execute this code. Right now, this will work without any compilation issue. And so the result is 23. So everything's fine here. Yeah, but what happens here? And what's the problem here? Here we want to pass double to integer. And here we see the problem. You know that the integer can be 1, 2, 3, 4 on integer number 1, 2, 3, 4, 5, 6, 7, and so on. But it cannot have decimal places. So what will happen? So the program by default does not understand what you expect here. What you expect here, and that's why you will see compilation error at this point. Yeah? Because it cannot really convert it by default from double to integer. What you need to do here? The option here is to do the same way as I did for the character. So I use the brackets and I provide the type inside. Yeah, so inside the brackets I provide the type, and right now, so let me compile and execute. Yeah, so right now we see that compilation is successful and is successfully executed, and the value is 2. So what actually happened? It just simply deleted the decimal places and just kept only 2. So this is how the casting works. We go from one type to another type. For the the casting operation in programming works actually differently for the. So if we work with the so right now we will only work with the we'll use casting only for the numbers. Because for the numbers, the idea is quite straightforward and simple. If we go from, basically when we talk about casting, then it means that we have two options. We go from more general to more precise, or from more precise to more general. And in this case, we go from more precise, which is 2.35, and more precise value, to more general, which is integer, which cannot be 2.35, it can be 2 or 3 or something else, for example, but it cannot be as precise as double. So in this case, we go from more precise value type to more general value type. If we do it this way, so it means that something will be lost. Yeah. So if we talk about type casting, so in this case, it should be 2. If I'm not mistaken, because it just simply cuts the moment. It just simply cuts the decimals. Yeah, it stays 2. It does not round. It simply cuts the remaining part. It just keeps the integer only. That's why it will stay 2. Yeah. Because the idea is simple. Casting operation just simply cuts the floating points. If you want to round, we'll see the math operations. So using math operations, we can actually round it, but we'll take a look on it a little bit later. Yeah. Okay. So that is about about this case. Yeah. So if we go, and always for the numbers, if we go from more specific number to more general, means that we will lose something during the casting operation, and that's why in this case we need to provide the idea to the program that we need to provide the information to the program that yes, we are fine, that we'll lose the data here, some data here, and that's why we need to use this operation. If we go to the opposite direction, it means that we go from more general to more precise, in this case we do not lose anything because all the integer numbers they are also decimal numbers. Yeah, so it's easy. We can consider in this case 23 as 23.00, for example. This will also be double. This will also be decimal number, right? That's why in this case we do not lose anything, and this happens automatically. We do not need this casting operation theory. We can provide it here, but I guess this will be allowed, but there's no actual need of this casting operation. Yeah, it is allowed, but it's not needed. So you can simply escape using it. But this idea, I mean, if we go from more precise to more general, to more precise, from more precise to more general, and if we go from more general to more precise type, then such idea with the casting works only for numbers, yeah, for integrals, yeah, for numbers. If we later on we will see how it works for the object types, yeah, for the classes, then in such cases actually you'll see that the casting works the opposite way. But this will be the next topic for us. We can see how the casting works for the numbers. Do you have any questions about the casting for the primitive types? If it's not 100% clear for you, don't worry, we will have the tasks, we will have the examples when you can also check it yourselves. Yeah, but and here you can also see the direction. Yeah, so there's winding casting. Yeah, if we convert, if we go from, as I said, more general to more precise, yeah, then this is called winding casting, and narrowing casting to go from more precise to more general. Yeah. So this type of casting is simple. Yeah, we do not lose anything. This type of casting is more complicated because during this operation we may lose some data. Yeah. And that's why it's more tricky case. All right. So if you have any questions, please let me know about the casting on narrowing of the numbers, number types. This is only for numbers and for characters as well, because actually characters can also be converted into the integers. What I showed you here. Yeah. Okay. So this is what I just said. Yeah, that I just said. We may have data rules. If we go from more precise to more general. And yeah, so C# is statically typed at compile time. After the variable is declared, it cannot be declared again or assigned a value of another type unless the type is implicitly convertible to the variable stack again. That's about statically typed programming. If we talk about let's say, for example, JavaScript, and JavaScript, yes, JavaScript that's will be the same. Yeah, if we talk about statically typed languages, then in those cases you may see something that the type of the variables can be changed. No, I guess for C#, for JavaScript this will not work, but so I work, for example, with such programming language called R. That's for statistics, and I guess for Python as well. Yeah, I have worked with Python just a little bit. I guess yeah, for Python this rule may be a little bit different. Though definitely is different for JPython. There is such language, and for such cases, for the languages, for non-statically typed languages, there may be such option that that you can declare if you multiple times, and at one point it will be string, at one point it will be boolean, at one point of execution of the program it will be something else, and so on. Yeah. So it can be changed, but for C#, and also for other statically typed programming languages like C++ or Java or something similar, then once the variable is declared, the type of it cannot be changed. So you cannot convert string to integer. Yeah. I mean, convert using assignment operation. There is the option that you maybe I will show you. So there is, yeah. So there is such option that you want, let's say you have the string, this would be number text. So number text. Let's say that there's some kind of number. Yeah, so in theory, this is number. Yeah, so why I can't use it as number? But it's obviously then you cannot let's say it's simple integer and that's the name of the variable. But of course I cannot pass the string to the integer. And you'll see that we will have compilation error, because we cannot convert string to integer. That makes sense. But so right now you can see that why I can't do it, because I have the number here. I can't assign it to integer. So there is an option, and the option is called parsing. Yeah. So I guess, to be honest, I have not really used the word parsing outside the programming. Maybe there are some cases outside of the programming world where parsing is used, but parsing actually means that you have some kind of text and you need to split it and then put it somewhere. You need to put it somewhere. So like in this case, I need to parse this text and put it into the integer value. And in C# you have such option. We can use int 32 class, and then we can use parse method. So I have not talked about, I have not explained to you how the methods works. So in this case, I'll just simply show. Actually, yeah, we already used the methods. For example, WriteLine, that's also the method, and I pass the argument to the method. We'll talk about methods maybe a little bit later, but the concept is simple that I call the method, the function. I can call it function. Then the function returns me something. Like in this case, it returns nothing. It just simply prints the output in console. In this case, the method returns the integer. And so that's the method from the class int32. It parses. I provide text to it, and it returns me the integer. We'll talk about methods a little bit later. Just as a small introduction, how we can achieve that we go from string to integer. So that's the option, and let me compile it. I have one warning, yeah, because it's never used, but that's just for example. Just for the example, maybe also let's print it out, just to make 100% sure that everything works as expected. Once again, compile and print it, and we can see that it is printed as the number. Yeah, so again, directly we cannot cast the text to pass text to integer, but we can use the predefined methods, operations, and not operations, actually we call them methods, from the classes, system classes, which then return, which then can take integers and then return the take strings and return integers. So that is how we can work around here, but of course directly the casting cannot be done without some special methods. And therefore, after declaring the variable as integer, you cannot assign the string to it. That's what I just showed to you. If you have any questions, please let me know. And yeah, actually there are some code examples. I just created the code example by myself. So we can also take, just to make it more interesting, let's take also the examples from the presentation. So maybe I'll create a new file. Okay, I need to select the language. Okay, indeed that was the reason why the formatter did not work. Okay, let's save. Okay, then it does this way. Okay, never mind. Let's then create a code, and I will call the let's call the class as the program, and then I will copy paste the code here, and let's see what's the result. A moment, let's double check. Okay, and the formatter still does not work. Yeah, I'll check it after this session. And let's then compile this program. .cs, and then let's execute. So let's go one by one. So we printed out the initial text, that's fine. Then we have this double, and then we need to convert. So then we converted double to integer, and then we get 5 in the result. So here's the result. Yeah. And in this case, we just simply apply the new value. And so there's nothing special here. So maybe I will comment it back. So that's casting, what I said. And right here, we assign double, then to integer to double. Of course, that will always be fine. And in this case, we can see that actually for status as 4, if we, maybe let's do it this way. So, and right now, let's try to go back from integer to double, and you'll see that the decimal places will actually be lost at this point. We'll copy paste these two lines. Oh, yeah, I actually declared that I don't do it. Okay. Yeah, you cannot. Yeah, one more point: you cannot declare the variable with the same name twice. That's not possible. You will have the compilation error. And the variable name should be unique. Okay. Oh, yeah, of course. That should be the first one. Oh no, I just simply. Yeah, I want to show that if we do the casting, then we will lose the. We'll actually lose the decimal points, and then they will not come back. And so we see that if I convert integer double to integer, I lose decimal digits, and if I convert back, then the decimal digits will not go back. Yeah. So that was the case here. Okay, let's move on. The keywords. So one moment. Okay, then let's maybe quickly talk about keywords and contextual keywords, and then next session we'll start with the examples. So in all the programming languages, you will see the keywords. In different programming languages, they may be different, and so we already used some of them. So we use the keywords for the data types like boolean, integer, should be here, and they all should be here. Then what we also use from these, we use class, we use namespace, it should be here as well. System is actually not the keyword, it's not actually the part of the hold on. Okay, we do not use the yeah, so this is quite an interesting thing. For console, you can see that we did not use namespace system here, and that's why we use system prefix for console here. So there's an option if you don't declare names using system, then you need to find this. You need to use system prefix here. What else did we use? So we used class, I said, types, and right now we have not used more. But so what's the point of keywords? Keywords have some special meaning. Keywords can be basically these are the words, yeah, and they can be the part of the statement. They can be the they can describe some kind of structures. Yeah, we'll later on see, for example, for abstract or for public, for private. Private should also be here, yes. Somewhere, yeah, protected, private. Yeah, so using such keywords, we can add some characteristics to different objects. Not objects, to different structures used in our code. Yeah. So one point for keywords: you cannot declare the variables using the same names and state names from the keywords. Yeah. So that's impossible. Keywords are reserved, and so mainly it means that again you cannot say I want to declare the variable double, or for a moment no, I guess it won't be possible. It should not be possible, because later on this will be one moment. Actually I never tried it, but this may be, yeah, of course this. It's not possible because actually it does not show the issue, but yeah, of course it should not be possible because this is the keyword. Keyword is reserved, and so what does it basically, why it is reserved and it's not possible to then reuse it? Because every time you use it in the code, then let's say if I say double, then it means that the code expects from me that I will declare the variable, yeah, with the type double. Yeah, I cannot say that I cannot have different usage of double. Yeah, it uses for the double variable declaration. Yeah. And the same is for all the other keywords. They are reserved. I will later on will use more of them, we'll use most of them. Yeah, and I will also see the meaning of them. Okay, see the question. Yeah, any questions you can type them. I guess we will finish with this slide. Maybe any questions? I see Vlad is typing. And Anastasia. After keywords can be any word. So Well, I not really understand your question. After keywords can be any word. Sometimes keywords can also be used for keywords. They can be mixed. No, keywords cannot be mixed, but I'm not really sure what do you mean for after keywords can be any word. So what do you really mean? The keywords are used differently. For example, if statements are written this way, so if statements may be written this way, so you should have the brackets after if, for example. Yeah, so that's the keyword for if. If keyword it requires the round brackets, for example. For different keywords, the meaning is different, and also the structure different. It can be double. For example, there was double number double, okay, but can it be double talk? Yes. So for doc, so doc is not the keyword. At least, yeah, doc is not keyword. So of course you can select any name you want, yeah, any name of the variable, except the keyword, and you can declare the variable this way and write the name as doc. It cannot be any. It cannot be the keyword, yeah. So you cannot say that double if. This will not be correct. So the name of the variable should not be keyword. That's for sure. You will see the error, but if it's doc, then of course it can be. Yeah. So you can select the name for the variable. It can be any name, but yeah, it's not used. But choose the warning that it's not used. But it's no error. It's not error. It can be. So the question for Anastasia, will there be the homework for this one? Yes, but I will. For this one, let's see. For this particular, I guess no. We'll have practical assignment with some more features. For, I guess that would be C# algorithms. This assignment I will share it a little bit later, and I will also declare the deadline also a little bit later, but nothing for now. Okay, the question from Asa, keyword, yeah, not after keyword, yeah, so please do not think that these all are the data types. Yeah, we declare the variables only for the data type, so you can use double, what else we have, bool, string, short, byte, and only the data types. Yeah, data type is not the same as keywords. Because data types, they are keywords, but not all the keywords are data types. So for keywords, there may be different usage, and we'll see how we use if, how we use if else if, how we use null, how we use new, how we use try. For example, true, that's the value. Yeah, that's not the data type, that's the value. Yeah, false, that's also not the data type, that's the value. The keyword basically means these, so just the simple explanation for the keywords, these are the reserved names which are used to declare some actions, some behavior of the program, and they cannot be used as the identifiers we create for the class names, for the method names, for the variable names. It means that we cannot use them as the names for something. Yeah. So these are reserved words which which define some kind of behavior for them. Okay. So, but if you have more questions, then you can let me know, and then I will reply to them in the chat. And during this session tomorrow, regarding this, should we submit the homework for Git, just practical assignment? Again, as I said, for Git, you just need to share the repository with me, and I will basically see what's inside the repository for your private repository, for your home tasks, and also for your group repository. Yeah. Okay, it seems that we should finish now. Okay, thank you. you very much then for your attention, and see you all tomorrow. Any questions, please let me know. We can discuss them tomorrow. Okay, thank you and have a nice evening, and see you tomorrow. Bye.